In this video, we're going to start looking at correlation, scatter plots, and trend lines. So let's start off with what is a scatter plot. A scatter plot is just a graph of points plotted to show a possible relationship between two sets of data. So correlation, what we're going to first focus on is the relationship between those things. So two data sets are related. That's not necessarily means that there causes an effect. It could be. But we have two different main types of correlation. We can have positive correlation, which means as one of your variables, x increases, y also increases. So we're also going to look at this from the perspective of what as x increases, what are your y values doing? So you can see here as my x values are getting larger, my y values are also getting larger. That's a positive correlation. Okay, we could also have negative correlation, which means that as your x increases, your y decreases. So generally we're going down, right, from left to right. As these x values are getting larger, your y values are getting smaller. Okay, or we could have no correlation, which would look something like this, where we just have a smattering of points. They don't tend to go up or down as your x increases. So let's just look at these and practice identifying that correlation. So here, as we're looking, as my x increases, as these temperatures increase, our sales are trending upwards as well. So this is a positive correlation. Okay, same thing here. As my weights are going up, my heights are also generally moving up. So this is also a positive correlation. Here, as the age of the car is going up, the value of the car is going down. So we have this general downward trend, and this is negative. And then finally here, as our side length of our square is increasing, the area of the square is increasing. You might notice this one's a little bit different because we're not linear up, we're making this curve. So it still has a positive correlation, but might be good to keep in mind that this is not linear. It's not a linear relationship there. Okay, so let's practice actually making some of our own scatter plots of what a relationship could look like, thinking about that correlation. So we're going to sketch a relationship between the outside temperature and the number of cups of hot chocolate sold. So we always want to be thinking, what is our dependent, independent variable? So here, if we're looking at temperature and cups of hot chocolate, right, your temperature is going to be the independent thing. That is not going to change based on how much hot chocolate, right? More hot chocolate sold is not going to affect the temperature. The temperature is what it is. And then we're looking at, does that have a relationship with your cups of hot chocolate? So if we're looking at this here, thinking about what might happen as your temperature increases, right, as it's getting warmer, we're probably going to sell less hot chocolate, right? Generally, that's more of a winter thing when it's colder. Okay, and again, we don't know exactly what this is going to look like. Wow, I'm drawing this backwards. But as your temperature increases, generally our cups of hot chocolate are probably decreasing, right? Most people don't want a cup of hot chocolate when it's 95 degrees outside. Okay. Let's look at another one here, relationship between the inches of snow overnight and the number of people at Bridger Bowl. Again, try and think of which one of those is going to be your independent variable. Right, the snow is going to happen whether or not anyone skis. So this is the inches of snow is your independent, your x values, and this is number of people. Okay, so as your inches of snow increase, what's going to happen to the number of people skiing? Right, more snow generally means that we have more skiers. So we'll look something like that with a positive correlation there. Okay, let's continue on here, shifting into our next topic, which is a line of best fit or a trend line. So a line of best fit is a trend line that best represents the data on a scatter plot. So even though all of your points might not fit perfectly in a line, we could represent that with some sort of line. So this line might pass through some of the points, might not go through any of the points, or it might go through all of the points depending on what your relationship looks like. So we're going to look at making a trend line for each of these scatter plots. So with your scatter plot, we want to go as many points as close as possible to the line, right? So you could say, oh, well, this line here goes through the middle of the data, but that's not following the trend of my data. I'm going to try and fit it so as many of these points are as close as possible to my line, and that decent, right? Yours might look a little different than mine because we're just eyeballing this at this point, making a trend line. Okay. So as our temperature is increasing, our sales are increasing, we're following kind of this general positive correlation trend. Okay, here, if we kind of follow along with our points here, try and get as many points as close as possible to that trend line. As our driver's age is increasing, the max distance to read the sign is decreasing. Hopefully that also makes sense. Okay, this one here, we don't know what we're talking about. We still draw a trend line. As my x's are increasing, my y's are increasing. So this is also positive correlation. Put a line in here, try and get it as close to as many points as possible. You can see like this one doesn't really go through many points, if any, but it's still equally splitting my data following that trend of the data. Okay, here again, we are looking at a negative correlation. As my x is increasing, my y is decreasing. And throwing in a trend line, I probably could have gone a little higher on that one. But generally, we're trying to fit our line as close as possible to as many points as possible. So this one probably would be a little better about there. Okay. But again, it's just a trend line, so we're just doing our best to eyeball it. We'll look more later at how to find the line of best fit that's calculated to actually be as close as possible to as many points as possible. Okay, so with that in mind, let's have a quick refresher of writing lines. Okay, we're going to use our slope-intercept form, so y equals mx plus b, where m is our slope, so this guy, and b is our y-intercept. And we are going to use our slope-intercept form to write some equations with these trend lines and lines of best fit. So to do that, we need to remember how to. So we're going to start off here by finding our slope. So when we're finding our slope, remember, it doesn't matter which one's y2, y1. Really, the important thing is that y2 goes with x2 and y1 goes with x1. So you could pick either of your y values to be your y2 value. I'm going to pick 4. And then that, the only important thing there is that 4 came from right there, has to go with the 2 that its point is. So that we have to have that 2 here as your x value. So you can see where those pieces came from when we're finding our slope. Okay. You could have also started with -2. That's fine. 4 minus -2. So that -2 is this guy right here. Get really clear since there are 2 -2's here. And then in the denominator, we have 2 minus -2, where this -2 is this -2. So again, you could have done that completely backwards as long as this y value goes with this x value and this y value goes with this x value. Okay, then simplify your slope here. So we're going to do 4 minus -2 is 6. 2 minus -2 is 4. Simplify if you can. So this is 3/2. Okay, once we have our slope, we still need to figure out what our y-intercept is. So we're going to go back to our equation here, y equals mx plus b, and I'm going to plug in a y value, either y value. So I'm going to use that 4 again. And then it equals our slope, 3/2 times the x value that goes with that y value, plus b. So we are going to use this to find that b value. So let's just show you quickly where those pieces are from. So this 4, 2 is just this xy point there. And then that b, 3/2 here, is that slope that we found there. So we're plugging in that slope, a y value, and the x value that goes with that y value. You could have used the other point too, to find b. And then once we have b, we'll plug it back into our y equals mx plus b. So 3/2 times 2, these 2's just divide out, that's 3. And then we're solving for b, so we get b is 1. And then we're going to put that back into our equation. So now we have our b value that we found right here, and we have our slope there. So we're just going to plug it back into y equals your slope x plus your b value. And that is your equation of the line that goes through these 2 points. So find your slope, use your y equals mx plus b to find b, plug it all back in. Okay, so let's take a look at finding our own line of best trend line from some data here. So here we have a large data set that's looking at the cricket chirps dependent are compared to temperature. So again, a good thing to think about which one should be your x and which one should be your y. So temperature is not going to be affected by cricket chirps, right? That's our independent. And then our cricket chirps will be our dependent variable. So when we're looking at these values, I don't have, let's see, 90 boxes or whatever I need to go all the way up to, let's say our highest here is 88.6. So since we don't have all of those values, we're just going to create our table. We're going to adjust our graph so that it fits to where we want to be. So if we're looking at labeling these axes, we can't get all the way up to where we want to get to. So what I'm going to do is do a little skip here. So that little thing just shows I'm not starting at 0. I'm going to skip all the way up to, let's start at, where's our lowest? 69. So I'm going to start at 68 and count by 2s. So then this would be 70, 72, 74, 76, 78, 80, 2, 4, 6, 8, 90, 2, 4. Okay, so that gets us up to where we want to be. And we're going to look at how does that relate to our cricket chirps. And so if we want to look at our cricket chirps here, you can see we're all in like the teens. So again, I'm going to skip up to 10 and then just go up by 1 for my cricket chirps. Let me 21, 22, 23. Okay, so now we have to plot some of these things. So we have 20 quick cricket chirps, 88.6, 82, 4, 6, 8. Okay, 88.6 is going to be about here. 16, 71. We're just plotting these points. 19.8. I don't know how you have 0.8 cricket chirps, but we did apparently. 93. 84.3 is 18.4. 80.6. 17.1. 75.2 is 15.5. Okay, so we just keep going until we've plotted all of these points so that we can get a good idea about where we are going with our graph. So you can probably already see some correlation here that it's looking like we have a positive correlation. 69.4, 15.4, almost there, 83, 16.2, 9, 15, 17.2, this is 82.6, 80.6, 16, 17, 83.5, and 76.3 is 14.4. Okay, so we have all of these points on our graph here. And we want to find the equation for the line of best fit using 2 points. So again, this is still going to be a trend line. We're just kind of eyeballing where we're at. But we're going to make the best line we can kind of through the middle of our data here and see, okay, where does it go through a couple of our points? And then maybe we can use those 2 points to help us out. So I'm looking, it goes through this point here, which is 74. There's no organization of this data whatsoever. 75, 15.5, this point. And look at this point right here, which is 82, that guy right there. Okay, so we're just going to utilize those 2 points to write an equation for this line. So again, we're starting to start by finding our slope. So our slope is going to be y2 minus y1 over x2 minus x1. Okay, it doesn't matter if you do those completely flip-flopped. Okay, we're going to get 17.1 minus 15.5, 1.6 over 82 minus 75.2, 6.8. So 1.6 divided by 6.8. Didn't put that in my calculator correctly. Is 4/17. Okay, so we have our slope, and then we need to find our y-intercept. So we're just going to pick a y value. I'm going to say 17.1 equals 4/17 times 82 plus b. So I'm going to take that thing times 82. Okay, that's what this number is here. And I'm going to subtract that from 17. And we get -2 5/17. Okay. One important thing to keep in mind is your line might not look exactly like my line because we picked our points based on where your trend line went through. So this is not an exact science, but this is my general trend line there. And that's how it goes, okay? So the y-intercept here is this -2.2 5/17. So what that means is that if your temperature is 0, you're gonna have -2 5/17 cricket chirps. At a temp of 0, there will be -2 5/17 chirps. Okay, which doesn't really make sense, right? You can have negative cricket chirps, but also you probably won't have crickets chirping if it's 0 degrees because they won't be alive. So interpret the slope. So think here we're finding the change in cricket chirps over the change in your temperature. So our crickets are going to increase 4 chirps for every 17 increase in temperature. So increase 4 chirps for every 17 degrees. Make a prediction for the temperature when there are 17 cricket chirps. Okay, so really our equation's a little backwards for this if we want to know our cricket chirps from temperature, but we can still utilize it to work through these points. So if I have my equation here, if I know the cricket chirps, that's y. So I'm going to say 17 cricket chirps equals 4/17x minus 2 5/17. Okay, and then we can just solve for x. So I'm going to take 17 plus 2 5/17. And I get this number. I'm just going to leave that in my calculator because that is 19.29 blah, blah, blah. And then I want to get rid of this 4/17. So you can divide by 4/17, or you can multiply by 17/4. That's the reciprocal. Oh, and that worked out really nicely. So we get 82 degrees. Okay, make a prediction for the temperature when there are 30 cricket chirps. So we have 30 cricket chirps. I want to know, what is my temperature? All right, so same process here. We're going to add 30 plus that 2 and 5/17. And then we're going to divide by 4/17. If you're going to do that, make sure you put it in parentheses. Otherwise, multiply by 17/4, and then your parentheses don't matter as much. So we get 137.25 degrees. Okay, does this seem reasonable? Probably not. It's probably not going to be 137.25 degrees. So really, this line that we have, we said it's not very reasonable at 0 because our crickets are not alive at 0 degrees. It's also not very reliable at the end, but it does have a good fit for this middle chunk of our data between some reasonable temperatures, so probably between like 60-ish to maybe up to 100. So we can utilize that and use our cricket chirps to predict temperature, or temperature to predict cricket chirps either direction. Okay, that is all I have for you today. Thanks so much for watching.